have two types of sources. One is data set, second one is inline. Got it? If you go for a sync, you have three types: data set, inline, and cache. So better put the word not as a data set for the title. Types of sources and syncs. If you talk about a source types, you have two things. Number one, data set, and number two, inline. So Venkat Krishna, please. Same thing in the sync types. You have three things. Number one, data set. Number two, inline. And number three, cache. These are the three things. What is a data set? First of all, data set, so many examples. Of course, not so many. In all examples, we have used data set. Not collection of sources, not collection of syncs. In source, we will use data set. In sync also, we are using data set. What is a data set? Simply general terms. Three different ways. Okay. Is a logical object which refers physical data object. This is one answer. Second answer, you can say what you said previously. Snapshot. Snapshot of physical data object. The definition given by the Microsoft. Okay, this is my definition, this is your definition, but all these definitions are waste. The final correct word is the definition given by the Microsoft. Okay, what they say is a pointer. Data set is a pointer to physical data object. Understand? A small example for this: the employee is your table or a file of data lake, or the Synapse or Azure SQL table, whatever it may be. You want to work with this table. You want to work with this table from the ADF means you have to create a data set. Okay. Suppose the data set name is ds_em. I am using this in data flow number 1. Same thing, ds_emp is a data set which refers emp table. I am using data flow number 10. ds_emp, same thing I am using in pipeline 100 in the copy data activity. Understand? Once I create a data set, what is the advantage to me? I can reuse that data set in any data flow, in any pipeline. Okay. Suppose in another pipeline 100. So in pipeline 100 in the copy data activity, I have used that. Again, same thing, same data set I am using in pipeline 200. Not in copy data activity, in lookup activity I am using. In pipeline 300, I am using the same thing in get metadata activity. That means data sets can be reused by multiple activities of pipeline and multiple data flows. That can be used as source or that can be used as even sync. Got it? So I repeat the thing, data set is reusable component, which can be used by multiple activities of pipeline, and at the same time multiple data flows, and also by power queries for data. Understood? So once if I create one data set for one particular physical file, I can use it anywhere. But there are, so whenever I data set created, once I publish this, what will happen? That will be available permanently. That will be available for you permanently. But there is a data set. The data set requirement is other different flows are not required, only within one flow that is required. The reason why I'm creating data set is, okay, in this data flow number one, I need that file, I need that data. In other data flow also, I need the data. In so many other activities also, I need that data. Okay, that means the reusage requirement is more. That's why I go for data sets. We are creating physical data set in ADF. Got it. But if I go with inline option to access your file, no need to create physical data set. Without physical data set, you can access the data. Without physical data set, you can access the physical. I am not asking physical file. I am asking about physical data set. Understand? Without creating physical data set, how you can read the data from a file or from a table means this should be the answer. Understand? So just I want to read data from EMP file. Just observe this. Want to read data from emp.txt file. The emp.txt is in our data lake account under my data container. I want to read this data from this file. I don't want to create a data set. What I do in my data flow? My data flow is df1. What is the first transformation? Source. For this source, it is asking source type. In the source type, instead of selecting data set, I will select inline. In the next tab, we have source options. Here it will ask you the file path. In the file path, we have three things: container, directory, and file. The container name I'm giving as my data. Under my data, I don't have any subdirectories. Directly file name emp.txt I'm using. Think that my source name is source1. After that, my complete flow is like this: source1. For this source1, I applied filter. For the filtered data, I applied aggregation. And then I am writing into the sync. This entire thing is my data flow. Got it? If I execute this, what will happen? If I execute this data flow, what will happen? It reads data from employee. Data will be filtered. And then aggregation is applied. And finally, data is written into sync. In the case of sync, I am giving a data set, ds underscore output. That is physical data set in ADF. This output to be used by many other data flows or many other activities. That's why physical data set I have used. So here also, if I use inline, there is no physical data set. Only file is created. Got it. So what is the data set name for this file now? There is no data set in ADF. Without data set, you are accessing data of a physical object. Got it. So based on this, I want you to answer this question. When to use data set? When to use inline? Of source types. I'm talking about source types. Same thing if you are working with sync, you have 3 sync types. We will be discussing about each and every one. Please answer me this question. When to use data set, when to use inline?
Depends on the scope.
Reusability is more. Reusability is more. Question number 1. At the time, go for data set. Same data required in data flow number 1, data flow number 2, data flow number 3. Understand? And also pipeline 1, pipeline 2, pipeline 3. Again, tomorrow, new pipelines, again, new data flows need that. Understood the point, sir? At the time, go for data set. Understood this? But there is a data set. Only in this data flow, only I need it. In remaining data flows, I don't need it. The remaining data flows, I don't need it. Requirement is very rare. Unnecessarily, I don't want to create a data set for that. Got the point, sir? Because too many people are creating noise, right? At the same time, so many data sets will create noise in the system also. We don't need it. Okay, this is one answer. And also, like I explained you, this is the reason one. Okay, not reason. What is the clarity? If data to be used by many data flows or pipeline. Directly pipeline don't use that. In the pipeline activities will use data. What are the activities that are using data? What are the activities that are using data? That needs to read data, get metadata, lookup data, lookup activity, copy data, such kind of. For each is not reading data from a file, man. For each is reading data from previous activity output, maybe get metadata output or lookup output like that. Understand? Activities that are working with physical components, maybe on-premise or maybe cloud. So if data to be used by many data flows or pipeline activities, then use data set. Data set as it can be source as or sync type. Okay. Second statement for this. Give the negation. Give some statement which supports to the inline. What is your answer? If reusage requirement is very less, then use inline. As source or sync type. Understood? If you select inline option, directly it is asking you file path from the source options. You just can give your container and your file. For example, if it is table, directly you can give the table. Only linked service you need to select. Linked service is mandatory. Without linked service, you cannot connect with the data source. Got it? The linked service. Let's say LS1. If it is SQL related linked service. If it is data lake, data lake related linked service you will be giving. Understood this? Okay, in our students, among all our students, I keep all the students. If you feel every student as a data, I keep as data set. Maybe one day absent, every day or repeatedly you are attending. Okay, suppose if you are a data, if you are a file, if you are a table, I am keeping all of you into the data. But today our guest is Sakshi. I keep it as inline. Okay, like this. Suppose today inline, tomorrow requirement is by till now 100 pipelines I have, 100 data flows I have, but only one time requirement till now. But tomorrow onwards requirements created more. Then I can turn this into data set. Understood all of you? So this is the small clarity. This inline data set type and inline. These two are available in both source and sync. Not only in data flows, you can observe in copy data activity also. Please verify that. Just go for a pipeline, just for testing. Let's drag the activity of copy data. Here, check for the sync. Is there any option? So here it is not showing any option. Here physical data set is mandatory, I think, for the copy data. In the sync, here also it is asking only data set. Okay. But in the data flows, any data flows, the first mandatory thing is source. In the case of source, you have options. In source, you have only two options. But in sync, additionally, you have cache option. Okay. Now let's talk about the third one. Cache. This is available only for data flows. In data flows, once you created a data flow, once you run a data flow, what will happen? That is converted as data bricks job. Data bricks means that is Spark in memory computing with MPP. In the case of Spark, there is a behavior called, there is an option called Spark cache. Did you remember about persistence? The data or the transformed data, which is to be used by many other flows, that will be persisted. So generally, in case of RDDs, if I convert, if a data flow is converted into RDD workflow, what will happen? If your flow is like RDD1, RDD1 to RDD2, RDD2, 3, RDD3, what is the working style? First R1 loaded, reads data, status ready, then waits for R2. Okay, once R2 loaded, start reading from R1, computation happened, then status ready. Whenever R2 status ready, R1 will be removed. But R3 to be used by many other data sets, then we are going to do persist. Even though R3 execution completed, its next RDD, R4 is ready, but still R3 transformation still available in the RAM. Okay, so this kind of feature for the data sets you want to provide, or for transformed results you want to provide, there is cache. There is the sync as cache. If sync is cache, it uses Spark cache. Okay, so that other transformations which requires same transformed results can access the data faster. Okay, but the limitation of this one, the Spark cache is limited to the session. Here, for every data flow, one separate session will be started. For example, here I have a, remember this important point. I have a data flow number one, data flow number two. Here I used cache. Here output one is there. It's not data set. Think that some transformed results have been written into this one. This output can be used by other, within this data flow. Within this data flow, different transformations are there. Multiple transformation can reuse the data. But if I come to this DF2, I cannot here the DF2 transformations, data flow transformations cannot reuse cache of data flow one. That means the cache is limited within a data flow. But there are some special cases. I want output of data flow 1 to be used by data flow 2. Understand? Some output I have written into this one, into the cache. This output is written by data flow 1, but I want to use that by data flow 2. That is the challenge. But technically, the architecture is limiting you. The cache sync is limited. The scope of that cache output is within a data flow, not out of a data flow. Got it? But my requirement demands it. Even the architecture is limiting that. My requirement is demanding it. I want that. So data flow 2 should, I want to use output of data flow 1. Got it? So all these are the technical challenges for you. Okay, how to overcome everything? I will demonstrate you step by step. Got clarity about this? Suppose in a data flow number 1, I am reading data from source 1, which is DS1, and I am performing some aggregation. Let's say the sum, aggregation is sum. The sum results, instead of writing into the output, I have written into cache. Again, the parallel flow, which is source 2, here DS2, here transformation 1. The transformation 1 can use cache. After that, transformation 2. After that, transformation 3. Again, the transformation 3 can use the cache output. Okay, finally, I am writing into my physical data set sync, which is DS underscore output. Got it? Now, just check this entire flow. There are two files, DS1 and DS2. DS1 is generating total sum. The sum it is writing into cache. Whatever the results that is written into the cache, that can be used by transformation 1, which is from source to transformation 2 if necessary. Of course, here it is not using, but transformation 3 is again using output of previous cache. Suppose if it is not cached, just to say this is the result is written. The result is written. The result is written by transformation 1 and transformation 3, and also by transformation 4, same result. Transformation 5 also needs same results. This is the story. The data is not written. At the time, what happened? What will happen? Already you know, Spark sessions, RDD flow. Suppose if my flow is like this, what will happen? Not Notepad. Let's go with Paint. Just check this. 1, transformation 2, transformation 3, transformation 4, transformation 5, transformation 6. This is the story. The third transformation is required by output of third transformation is required by other different transformations. If I run this, what will happen? If I run this, what will happen? What will happen, sir? Your flow execution starts from beginning. After that, if I run this, again flow starts from beginning. Instead of doing that, if I persist this, what will happen? First time only entire flow will be executed. Next time onwards, remaining transformations can directly reuse that one or not. Similar kind of behavior. Understood this? Where is our notepad? Like this. That's why I want reusage of that one. That's why the result I am writing into cache. Whenever this transformation 3 needs that result immediately from the memory, it will fetch that result. Got it? Depends on your cluster size of your data bricks. The cached content will be distributed into multi-node memories, not in single CPU memory. Understood this? So final summary about this session. Every time you are using source and sink for reading, for writing. For reading transformations, you have two options, data set and inline. For sync, data set, inline, additionally, cache. Okay. So it is caching your result, transformed result into memory, not into the disk. Understood this? Okay. Just meeting time is up. Just terminating this meeting. Immediately rejoin into the next meeting. I'm going to demonstrate about cache in the next session. Okay. And different scenarios we'll be seeing on that. All of you give me 10 minutes break, sir. Today little long, up to 10 or 10:15. I will continue the session.